believe that we shall finally reach a last point, beyond which there is nothing, not even empty space. Similarly, if in imagination we travel backwards or forwards in time, it is difficult to believe that we shall reach a first or last time, with not even empty time beyond it. Thus space and time appear to be infinite in extent. Again, if we take any 2 points on a line, it seems evident that there must be other points between them, however small the distance between them may be. Every distance can be halved, and the halves can be halved again, and so on ad infinitum. In time, similarly, however little time may elapse between 2 moments, it seems evident that there will be other moments between them. Thus, space and time appear to be infinitely divisible. But as against these apparent facts, infinite extent and infinite divisibility, philosophers have advanced arguments tending to show that there could be no infinite collections of things, and that therefore the number of points in space, or of instants in time, must be finite. Thus a contradiction emerged between the apparent nature of space and time and the supposed impossibility of infinite collections. Kant, who first emphasized this contradiction, deduced the impossibility of space and time, which he declared to be merely subjective. And since his time, very many philosophers have believed that space and time are mere appearance, not characteristic of the world as it really is. Now, however, owing to the labors of the mathematicians, notably Georg Cantor, it has appeared that the impossibility of infinite collections was a mistake. They are not, in fact, self-contradictory, but only contradictory of certain rather obstinate mental prejudices. Hence the reason for regarding space and time as unreal have become inoperative, and one of the great sources of metaphysical constructions is dried up. The mathematicians, however, have not been content with showing that space, as it is commonly supposed to be, is possible. They have shown also that many other forms of space are equally possible, so far as logic can show. Some of Euclid's axioms, which appear to common sense to be necessary, and were formerly supposed to be necessary by philosophers, are now known to derive their appearance of necessity from our mere familiarity with actual space, and not from any a priori logical foundation. By imagining worlds in which these axioms are false, the mathematicians have used logic to loosen the prejudices of common sense, and to show the possibility of spaces differing, some more, some less, from that in which we live. And some of these spaces differ so little from Euclidean space, where distances such as we can measure are concerned, that it is impossible to discover by observation whether our actual space is strictly Euclidean, or of one of these other kinds. Thus the position is completely reversed. Formerly it appeared that experience left only one kind of space to logic, and logic showed this one kind to be impossible. Now logic presents many kinds of space as possible apart from experience, and experience only partially decides between them. Thus, while our knowledge of what is has become less than it was formerly supposed to be, our knowledge of what may be is enormously increased. Instead of being shut in within narrow walls of which every nook and cranny could be explored, we find ourselves in an open world of free possibilities, where much remains unknown because there is so much to know. What has happened in the case of space and time has happened to some extent in other directions as well. The attempt to prescribe to the universe by means of a priori principles has broken down. Logic, instead of being, as formerly, the bar to possibilities, has become the great liberator of the imagination, presenting innumerable alternatives which are closed to unreflective common sense, and leaving to experience the task of deciding, where decision is possible, between the many worlds which logic offers for our choice. Thus knowledge as to what exists becomes limited to what we can learn from experience, not to what we can actually experience. For as we have seen, there is much knowledge by description concerning things of which we have no direct experience. But in all cases of knowledge by description, we need some connection of universals, enabling us from such and such a datum to infer an object of a certain sort as implied by our datum. Thus, in regard to physical objects, for example, the principle that sense data are signs of physical objects is itself a connection of universals, and it is only in virtue of this principle that experience enables us to acquire knowledge concerning physical objects. The same applies to the law of causality, or to descend to what is less general, to such principles as the law of gravitation. Principles such as the law of gravitation are proved, or rather are rendered highly probable,